summer. It's Beth and Hil here. Yay! Is everyone excited? We love the summer solstice. We thought we'd take a second to just kind of show you what satellites see Earth like. This might be what we would see if we were sitting on a satellite because we see visible light. So we'd probably see some green and some clouds and blue ocean. But we're going to go through some data sets.
First,
Ooh.
Let's not ignore what's going on in this image here. We notice this huge low pressure system hanging out in the Gulf of Mexico. We don't think it's going to turn into a hurricane, but maybe a tropical storm. So if you're in Louisiana, get ready for some moisture headed your way.
It's the first time I've ever read a potential tropical storm. So that's kind of an interesting thing, that it's really close to a tropical storm there, and I think, yeah, Louisiana might be getting quite a bit of, I don't know what, storm surge, some flooding.
Yeah, so quite the introduction to summer for the Gulf Coast, as we are in the middle of hurricane season now. It started June 1st.
I was just going to say, we're kind of in the beginning.
Well, yeah, that's true. We're a few weeks in, still a long way to go.
And we really plan to finish this with hurricanes. So we're going to jump straight to kind of seasons and temperature first. So,
so what are we looking at here, Hilary?
We are looking at land surface temperature. So land surface temperature is actually a little bit different than air temperature. And that is, this is actually, if you were to reach down, touch the ground, what's the temperature of the Earth?
Right, so does that change faster or slower than air?
It does change faster, actually, and I think that's because air probably has a little bit more water content.
Sure.
So water changes slower. Obviously, the oceans change the slowest.
Yes.
But yeah, you have a pretty large difference between blue and orange here in our color bar.
Yeah, and we're looking at a whole year-long loop. So if we jump, we're in winter now, and we can notice if we bring down the poles just how cold it is up at those poles. But if we speed up a little bit and get closer to today, we can see just how much it warms up through the spring, getting into summer. And of course, solstice means it's going to be our day with the most amount of daylight. So lots of heating can happen today.
Here in the northern hemisphere.
Here in the northern hemisphere.
Yes.
So
shortest day.
Southern hemisphere.
Yeah, if we have some people from
there.
Australia, because I think we've had some folks from Australia.
They're getting their shortest day down there.
Shortest day of the year down there.
Winter at the South Pole, very cold place to be right now for sure. So that's a little look at temperature changes through the year, and as temperatures change, there's a lot of impacts that we see with those. So if we wanted to jump to atmosphere, of course we were talking about air temperature and land temperature are different, but as the air temperature changes, one of the big things we see is the impact it has on weather. So what are we looking at here, Hilary?
We're looking at what we call wind streamers, and the wind streamers are according to not temperature but speed. Mm-hmm. So the deeper the red, the faster.
So right through there.
The faster the winds. And what we're also seeing is, so this is the 250 millibar height, which is basically where airplanes fly. It's where weather happens. But it's also, as you probably know a little bit better than me, since you're a meteorologist, this is where our jet stream is visible.
Sure, and the position of the jet stream is going to change with the seasons. So in the summertime, when it's warm at the equator and getting warmer at the poles, we're going to see that jet stream shifting northward. In the winter, when you have an extreme temperature difference with warm at the poles, or warm at the equator and cold at the poles, we're going to see that jet stream shift further south. So summertime, we're seeing that jet stream starting to come up. And when you get those temperature differences, that's when we're going to get those big, strong wind areas moving through.
So also, I just wanted to point out, a lot of the real-time data sets that we look at on SOS Explorer are actually past, right? So those are observations by satellites. This particular data set, as you might notice, is actually future. We're looking at the future. So that's a computer model generated.
Sure.
Data set, and so this one is particularly called the FIM forecast model, which is a really big mouthful, which I'm not going to go into, but it is a research model here in our group. at the Global Systems Division.
So that's a look at the wind streamers, maybe a little unfamiliar. What we can look at instead are the clouds and see
What that forecast, that exact time period.
Yeah, so check out our storm system here. You can see it doesn't turn into a hurricane with that nice tight eye, but it does bring lots of moisture into the Gulf and the whole southeast, it looks like. So over the next couple days, keep your eyes on that to see how that's developing.
Yeah, and I will just mention, a lot of people like to ask questions like, what do tornadoes look like on Science on a Sphere? It's really hard to see tornadoes because they're so small for the scale that we're looking at. But anytime that you have these kind of long fronts, so really long, curved, lots of clouds, lots of high, very reflective white clouds, you're looking at areas that could have thunderstorms and tornadoes. So this kind of stuff could even, who knows? You could get a tropical storm and a tornado.
Some severe weather out of it. Yeah, big cold front. You've got that boundary between warm and cold air. Definitely could see some severe weather in those areas.
So what does all this weather do to the look of the Earth?
That's a great question. We of course need precip for vegetation. So what we're looking at here is a year-long loop of vegetation, and satellites are actually used to detect this. They're able to see changes in vegetation over the course of the year. Now, if we look in areas like Australia, a lot of deserts there, not necessarily a lot of vegetation. But check out the green up that's going over Asia through the seasons. We dry out during the winters, and then as that sunlight comes and lots of precip with it too, we get lots of growth. Check out the forest up here, really greening up. That's a huge sink for carbon dioxide, all of those great forests over there. And certainly we see these huge changes that are really important. So right now it's hard to see the label behind my head here, but we're in June, and check out Europe, really greening up nicely. And if we jump back to December, you can see that change that happens over the seasons, certainly.
What I like to point out in certain data sets like this that have to do with vegetation is that this is a huge, this is the carbon cycle, really, in effect.
Absolutely.
So we have the carbon dioxide concentrations in the northern hemisphere are actually dropping pretty dramatically this time of year. By the end of the summer, they are the lowest that they are throughout the entire year. September in the northern hemisphere, carbon dioxide drops because there are all these plants that have been taking up CO2 all summer, and it actually declines. But then in the wintertime, you have the opposite effect, and not as much of that effect in the southern hemisphere. So if you look at the southern hemisphere, you might notice there's quite a lot less.
A lot of ocean.
Forest and land, so that kind of brings me to, is the land the only thing that actually photosynthesizes?
What do you guys think? Because it turns out there's a lot of plants in the ocean. So phytoplankton, it's at the base of the food chain in the oceans, and it's responsible for half of the oxygen on Earth, actually. So what we're looking at here is another satellite view of the Earth, looking at chlorophyll concentration. And of course, where we have chlorophyll, we're going to have phytoplankton.
Right, and we're going to have green. We call this ocean color because satellites actually look in these RGB channels. So they don't see things like we do, but they see this kind of red, blue, green. And what's happening is the ocean is actually colored according to satellites because they, these areas that have this chlorophyll pigment actually reflect green.
Yeah.
So
now, why are some areas greener than others?
Well, you have more chlorophyll concentration in those areas. So what we have here on this color scale is 0 is blue and 30 is green. So 30 milligrams per meter cubed. Who knows what that means exactly, but we do know that that's a lot of chlorophyll versus none. And so we do have areas of the ocean, very many areas of the ocean that are kind of like deserts.
Yeah, so these blue areas, not a whole lot going on in here. You wouldn't want to go fishing out in the middle of the Pacific.
Which is interesting, right? Like, I didn't really realize that until I started working here, that there are areas of the ocean, and really the best fishing is near the continents.
Sure.
So Why is that? Why is there more nutrients along the continents? And we've talked about this before
We have.
in our live stream.
Some of it is upwelling, right?
Sure.
So we're going to get lots of nutrients. The cold, deep ocean has a lot of nutrients in it. That upwelling along some of our coastlines brings it up. Some of it's runoff from land. If we look, say, off where the Amazon's coming out, lots of chlorophyll and phytoplankton there because of all of those nutrients from the river.
They also call
coming out.
phytoplankton microalgae.
Yeah.
But yeah, because you're getting all those nutrients running off from the oceans, or sorry, from the land through the rivers. But also, we've talked a little bit about before. There's also fertilizer that's coming off of certain areas, especially the Mississippi River Delta.
Yeah. And we see, even at the poles, there's lots of this going on. So it's not a matter of cold water and warm water, but a matter of where nutrients are. And a lot of times cold water does have
more
nutrients for sure.
Yeah.
But we can see those in the warmer areas.
But it doesn't just have to come out through rivers. It can actually just blow off the land. So we also get that effect here from the sand blowing off the Sahara's carrying nutrients.
Yeah.
As little as we would think.
So let's get another look at the oceans. We were just talking about the temperatures of them. And since it is summer in the northern hemisphere, people are probably thinking about their beach vacations. So let's take a look at sea surface temperature over the course of a year. So in this loop, we're in August of last year, and check out these ocean temperatures. Really warm.
That's about 90 degrees, by the way. Yeah.
So Gulf of Mexico, East
Fahrenheit.
Coast, you can see that Gulf Stream bringing that warm water up along the coast. California, it's still cold there. They've got upwelling going on. They don't have a Gulf Stream bringing that warm water
Well,
up.
and the ocean gyres move in a clockwise direction, so you're getting, if you
Cold
really
water.
follow my hand, where is it coming from on this side, where is it coming from on this side?
Yeah.
So what you get is this sort of from the equator up the east coast of every continent, actually,
Yeah,
and down the west
if we
coast.
take a peek over here, it's not quite as pronounced, but there is some warmer water creeping its way up along the coast of Japan. It's called the Hiroshima Current. And we're in April right now. As we proceed through the year, we're coming into May, we can see that warmer water coming through. Now, warm water has a big impact. We started with this. It's a nice place to wrap up. We started with hurricanes. We said hurricane season started June 1st. It runs through the end of November, and part of that has to do with ocean temperatures. So here we are.
June of last year.
June of last
So you
year.
can kind of see what happens through the summer, and then once we get into the cooler months, this is why we don't have hurricanes.
Because warm water is like fuel for a hurricane, and we need that as a key ingredient to sustain these hurricanes. So as our oceans are warming up through the summer, keep your eye on the Hurricane Center NOAA issues, watches, and warnings. So if you live in an area that's prone to hurricanes, definitely pay attention to what the Weather Service is saying about hurricanes so that you can be in a safe spot.
Do you know, did they predict a normal,
I've heard that we're
normal?
supposed to have an above average season this year, so definitely keep an eye on that. Now, Hillary, what'd you just load here?
I just loaded cumulative hurricane tracks from 1950 to 2005. So essentially we're looking at where hurricanes have moved, where they began and where they dissipated.
Great.
All over the world. So even though we call hurricanes in the Atlantic, they're called typhoons here.
Yeah.
So we still call
And
them essentially tropical storms.
cyclones in this region.
And I've actually heard that supposedly they call them Willy Willies here, but I don't know
Any
if that's...
Australians out there to verify that
Willy
for
Willies?
us?
Is this a rumor, or do you actually call them that? So here's the cool question, Beth. Why are there no hurricanes crossing the equator?
Well, we know that hurricanes in the northern hemisphere are going to rotate in a counterclockwise rotation because they're low pressure systems. In the southern hemisphere, they're going to rotate the opposite way, and it's all due to the Earth's rotation causing Coriolis force. So along the equator, we don't experience that Coriolis force.
There's zero.
Right.
So a hurricane would have to, and supposedly I've read that it's possible to cross the equator, and then it's happened maybe once, but they would have to switch directions, and they would basically have to go through a zero Coriolis effect, which is interesting because it's 5 degrees north and 5 degrees south, so that's a pretty large distance that they would have to move.
Yeah. Well, and you can see most storms, like if we look at the Atlantic, they tend to start in this region and then arch up this way. Just the way the atmosphere is flowing, that's going to be the general path of these storms. So it would be pretty unusual for one to take a dip in the other direction, but
supposedly it's possible.
It could happen.
Yeah, so let's keep our eye on hurricane season, and hopefully they don't have too much severe weather down in the southeast. Thanks for following us. Again,
Happy summer!
We are Beth and Hilary from the SOS team here in Boulder, Colorado, and you can learn more about Science on a Sphere at sos.noaa.gov, and we also are playing around with our exhibit version of SOS, which is called SOS Explorer. So any feedback is welcome. Thank you.
Thanks, guys.
Yay.